All right, we're talking about numerical limits. We are getting, okay, so for graphical limits, right? What I told you is we're getting closer and closer to some spot, right? Some X value. And we can look at that and we can see it, right? You can see where it's going graphically. Okay, how do we do that numerically? That's the question. Yeah. We want to get we want to get closer and closer from both sides. Maybe we have to come from both sides. So we're going to numerically analyze all these values heading towards 3. And we're going to see what that y value becomes. Okay. Because a lot of these functions that we're doing this with, you can't graph them and see it. Okay. The more you zoom in, it just keeps doing the same thing. You can't isolate a point. Okay. So the one I want to look at first that one. Okay. We're going to take the limit as x approaches 0. Oh, I don't bounce. Sin x over x. Your book doesn't do this justice. So if you're looking in your book for examples, it's going to be a little different than I show you, because I think the way I show is better. Okay. We're going to 0, so what numbers do we need to use on each side of it? 0 is our goal.
And then, that's fine. Yeah. Oh, no.
Right. So we're starting far away and getting closer and closer from the negative side, right?
And then
0. And then over here, start from the right, the positive side, and get closer and closer to it, right? Because these numbers get smaller and smaller. The question is, what are those values? Right? The big question is, what's this one? Right here. That's what we want. Error. What happens if I plug 0 in? Error. You get an error. Okay. Oh, what happens? I don't know. That's your first try. With any limit, just plug a number in and see what works. Sometimes you get lucky. Or sometimes you're blessed, I should say. So we need to analyze what's going on around it so that we can figure out where we're going. Okay. Because see how we plug 0 in and it doesn't give you a value? It's called an indeterminate form. We need to figure out what's headed towards where these are going. Because we're going to Denver, we can figure out if we're going to Denver when the value of the function is Colorado Springs. Remember that? Where are we going?
Yeah, but why are we using that
Good example. Yes. Okay, so here's how we're going to handle this. It's much easier on the calculator. So if you don't have one, go get one. I give in. Put sine x over x in your y equals. Making sure, I was gonna say first, Mikey. Making sure first that you are in radians mode. We're in calculus now, we're in radians mode. Go to mode. Radians. Okay. No, I'm pretty sure that would mess with us a little bit. Okay, go to your y equals screen. And put in sine x divided by x. No, it's a function. So. We're going to use our tables to do this for us. We don't have to type a whole bunch of stuff. Table set, so it's second window. Okay, our table start is 0. That's our limit, right? All right, now we want to go to our change in table. 0.001 was one of our intervals, right? Now go to your table. You're gonna have to go look at it. Second graph. Your table. Okay, so the value at 0.001 is 0.9999998. You need to write all the decimals in. Not the threes. Go into overnight.
So the 1, 2, 3, all that, is that just because it means that y would have been 1? Or did you have to
Say that again.
Okay, so you implemented
Yeah.
But you didn't have to do the y column?
No, because the function, it calculates the values. It plugs all the x's in for you.
Oh, okay.
This is why.
It does have to do the function. Oh,
Okay, so those are your two values for negative 0.001 and 0.001. Write them in your table.
how many 9s do you have?
6.
6.
8.
Right? Usually we'll want to start with the outside, but it doesn't really matter. Okay. Go back to your calculator now. Table set. And all you need to put your start again at 0. And change your change in table to 0.01. And it's going to give you the next set. It only has 4 9s this next, so you don't even have to look at it. Okay. And then you can go to your table set again. Change it to 0.1. And it gives you 2 9s. Okay. So this was 0.99998. This was 0.998. Okay, where are those going? 1? No. 1.
Oh,
Limit. X approaching 0. Sin x over x equals 1. Yes. You've numerically analyzed the limit. All right? You do have to show the table. If you're asked to numerically analyze the limit. If you wanted to, you could write, to make your life easier, since this is f of x, you could just write f of x. Because it's defined already. So either one works, doesn't matter. Okay.
But only if it's a question. Wait, do you do that for everyone, or is that like gonna be a problem?
What?
No.
It's an example of one, I think.
Oh,
I don't think it's a problem.
but if there is a question,
Basically. This is tedious enough, and I'm going to give you another few methods to solve these, but you're not going to use it very often at all. Okay, but it's got to be, it's good for you to see the graphical method and the numerical method first, so you know what a limit is, before I start showing you plug and chug and algebra and sandwich method and stuff like that. Okay? So, yeah, the squeeze theorem. Some people call it the sandwich theorem. Is this enough of an example for you? Okay. I think that covers numerical limits. Our book, if you look at the book, they orient these tables vertically. They put these numbers vertically. I don't like that because I like to be able to see them going together. Okay, so I suggest horizontally. The book does it vertically. So you can use it if it works for you, fine. But I prefer this. What happens if these numbers don't go to the same spot?
and you don't know how to get this.
One of those exists. Yeah. Okay. What if? Let's try this real quick.
Probably
Okay, we're approaching 0 again. Okay, go. When you get numbers, tell them. Yeah. Why do I always do that? I'm like Mr. Mistake. Can't do nothing. I'm off the bad way. An error in everything I do. Does anybody have any numbers for me?
Yeah, 1 million.
For what?
0.001.
Yeah.
100.1.
Is this going to be 10,000?
Yeah, I got 1 million for you.
I bet you this is a million as well, right? Is this 10,000? Oh, what's happening? Yeah. 0 is an asymptote in this one. See how these numbers are getting really big? You're never going to get together. Okay? This is going to infinity. Okay? The limit does not exist. They never come together. The graph looks like this. Yeah. That's what the graph looks like. So they're never actually coming together. They just keep going. Right?
Got it.
I did just look at the graph.
You can on that one, you can. Yeah. I don't know. Yeah. Okay, now, let's make sure we got this. That's an answer. Okay. So the left limit's infinity.
right limit? Right. They match, but this is the odd case where they don't come together, so you have to say it does not exist for. So be careful on that one. But this. No, look what I wrote. That's right, all that. That's only this side. This is only the right side. This is the both sides. They never come together.
You have to write all that for you?
No, I was just making sure that
Oh, what's your answer?
this is the answer for the original question. Partner up. Let's the bell's probably gonna ring while we're out there, so let's make sure we write the work down first. Okay, here it is.
It's 2.4.
2.2.
Is it on 2.2?
That is, that's more.
3943.
Okay, that's fine.
49 and 55. Some of these are graphical.
Yes.
I will spare you the spiraling tonight. You're welcome. Bring a pencil and a pen and a calculator.